Hello students, in this video we will be solving problems from exercise 8.3 and our first question is to evaluate, and under that we will have a few problems to solve. So our first problem is sine 18 degrees upon cos 72 degrees. Now this comes under the complementary angles that we learn with respect to trigonometry. If you have a close look, if you just forget for a while this sine and cos and have a look at the degrees, 18 degrees and 72 degrees, they share a relationship with respect to complementary angle. Complementary angles means what? That angle A and angle B together form 90 degrees. So over here, if you have a look, this is 18 degrees. If to that 18 degrees we add 72 degrees, we will get 90 degrees. And if you clearly have a look that the angle in the denominator is 72 degrees. So our objective over here will be to convert this 18 degrees to 72 degrees. How we can do that? See, sine 18 degrees can also be written as 90 degrees minus 72 degrees. Okay, because 90 degrees minus 72 degrees gives us 18 degrees. So we are not changing anything. We are just writing it in another way. 18 degrees is written in another way. 90 degrees minus 7. So expressing it in the form of a complementary angle. And we know from our previous video on complementary angles, we know that sine of 90 degrees minus theta in the angle is equal to cos theta. See, sine gives us cos theta when it comes to complementary angles, and cos theta gives us sin theta. Okay, so sine of 90 degrees minus the theta, here the theta is what? 72 degrees. So it gives us sine of 90 degrees minus theta gives us sine cos theta, the opposite, cos theta. Okay, so here this will give us, we write this upon cos 72 degrees. So this will give us cos of 72 degrees, the theta. Here theta is 72 degrees. So it gives us opposite of sine, cos, with that angle over here. The angle over here is 72 degrees. So it gives us cos 72. So it is cos 72 degrees over cos 72 degrees. These two cancel and we get the value as 1. So that's how we solve this problem with the help of complementary angles in trigonometry. Our next problem is tan 36 degrees upon cot 64 degrees. Once again, we can express tan 36 as tan of 90 degrees minus 64 degrees. See, 90 degrees minus 64 degrees gives us 36 degrees. But we have to also look at what is there in the denominator. It is 64 degrees. So we can, now I'll rewrite this first, the denominator, cot 64 degrees. Tan of 90 degrees minus 64 degrees. So tan of 90 degrees minus theta gives us what? Opposite of that is cot theta. Similar. So if tan theta gives us cot theta gives us tan theta. Okay, in terms of complementary angle. So tan of 90 degrees minus 64 degrees can be written as cot of 64 degrees upon cot of 64 degrees. These two cancel and once again we get our answer as 1. Our next problem is cos 48 degrees minus sin 42 degrees. So we have to change, remember we have to change only one. Okay, if we change both then we'll just get the opposite of each other. We have to only change one so that we can establish a relationship with the other term. Now we can change either this one or this one, comes to the same. We'll look to change the first term. So cos 48 can also be written as cos of 90 degrees minus 42, because 42 plus 48 gives us 90 minus sin 42. This will keep the way it is, and cos of 42 degrees is nothing but sine of 42 degrees minus sine 42 degrees, which is nothing but 0. Okay, so you see how we, without actually finding out the sign of that particular degree, we can get the value, total value, when we evaluate this particular problem. The last problem under question 1 is cosec 31 degrees minus sec 59 degrees. So cosec opposite will be sec and sec opposite will be cosec. Kindly refer to the video where we have done or explained about complementary angles, the various opposites of each other or complements of each other, you can say. Cosec 31 degrees minus sec 30. So here again, once again, we can either choose to change the first term or change the second term. Since in the previous problem I had changed the first term, this time let us try the second term and see if we get anything different. So cosec 31, I'll just write it the way it is, and sec 59 can be written as 90 degrees minus 31 degrees, because 31 degrees plus 59 degrees gives us 90 degrees. So it is okay to write sec 59 degrees as sec 90 degrees minus 31 degrees. Now once again we have discussed over here, opposite of sec is cosec. So cosec, I'll just write the first term the way it is, sec cosec 31 degrees, and sec 90 degrees minus 31 degrees can be written as cosec 31 degrees. So once again these two cancel out, we get the answer as 0. So I hope you have understood how we solved such problems in trigonometry. Let's move to the second question under exercise 8.3. So the second question says show that. So we need to show left hand side is equal to right hand side, as we see from the first problem under question 2. Slightly different type of problem compared to what we have solved in the first question, but let's see how we can use our knowledge of complementary angles to solve this one. So in this case we start with the left hand side, and let's see if we can actually prove it equal to the right hand side, because it is said show that. Left hand side says what? 1048 degrees, 1023 degrees, 1042 degrees and 1067 degrees. Now if you have a look closely, we can easily group 1048 and 1042 together, and we can group 1023 and 67 together, because 48 plus 42 gives us 90 and 23 and 67 also gives us 90. So first we'll just rearrange them together and group them in a bracket. 1048 degrees into 1042 degrees, and I'll put this in a bracket, multiplied, everything is multiplied actually. Another bracket will be of 1023 degrees into 1067 degrees. So 1048 can be written as 10 of 90 degrees. I'll put this in a bigger box bracket. 1090 degrees minus 42 degrees into 1042 degrees into box bracket, and 1023 I can write it as 10 of not a box bracket, 90 degrees minus 67 degrees into 1067 degrees, and I close it with a box bracket. So 10 of 90 degrees minus 42 degrees becomes cot 42 degrees, complement of that, into 1042. I write it the way it is. I close this bracket this way, and the other bracket is 10 of 90 degrees minus 67 degrees can be written as cot of 67 degrees into 10 of 67 degrees, and I close this bracket. Now from our identities we have also learned that cot is reciprocal of 10, so we can write cot 42 as 1 upon 1042 degrees into 1042 degrees, and once again over here cot 67 degrees can be written as 1 upon 1067 degrees into 1067 degrees. Now I can cancel this and even this. Ultimately what is remaining? Here 1 is remaining, 1 is remaining. So it is actually 1 into 1, which is nothing but 1, which is equal to right hand side. And thus we can say that whatever the equation is equal to right hand side. And that's how we get to prove this part. Our second problem under question 2 says cos 38 degrees into cos 52 degrees minus sin 38 degrees into sin 52 degrees. We need to show that equal to 0. So once again we begin with our left hand side and try to prove it equal to the right hand side, which is equal to 0. So left hand side is what? Cos 38 degrees into cos 52 degrees minus sin 38 degrees into sin 52 degrees. Okay, now if you carefully have a look at both these terms, what I mean is these two, okay, cos 38 and cos 52 degrees and sin 38 and 52 degrees. If you have a look at both of them, we can convert them into something similar so that we can cancel out, because we need these two terms to cancel out to give us 0. What we'll do over here, if we have a look, 38 plus 52 should give us 90. Same thing over here. So cos of 38 degrees can be written as cos of 90 degrees minus 52 degrees, because 52 plus 38 gives us 90, into cos 52 degrees. And similarly over here, what we can do is change this sin 38 into sine of 90 degrees minus 52 degrees, okay, into sine 52 degrees. So you have cos of 90 degrees minus 52 degrees can be written as complement of that is sine 52 degrees into cos 52 degrees minus sine of 90 degrees minus 52 degrees can be written as cos of 52 degrees into sine of 52 degrees. Okay, so now if you have a look, these are almost the same. Sine 52 degrees, cos 52 degrees, they are multiplied with each other. And here you have sine 52 degrees and cos 52 degrees. Same terms and they are subtracting each other, which means we get answer is 0, which is equal to right hand side. Thus we can show this left hand side equal to right hand side. So with this we complete the second question under exercise 8.3. If you have liked the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notifications whenever a new video is posted. Thanks for watching. See you in the next video.